Hi, in this video, I'm going to go over two challenging equations for seventh grade. I'm going to go over one with variables on both sides, and then I'm going to go over another one that has the distributive property. So let's get started. If you have the solving equations packet, you are on page 11, and I'm going to actually just focus on equation 2. So I'm just going to do C2, this one. Okay, so normally when we solve, the first thing we do is we subtract the constant from both sides. But I notice that this is not like my typical equations, my typical two-step equations, because my typical two-step equation, there would be a variable term plus a constant, plus or minus a constant, and on the other side, there'd be another constant. But this actually has variables on both sides. And what a lot of kids say is like it has two equations, but it's still just one equation. It's just that there's variables on both sides. So this kind of goes back to when we had the bags and coins and we had bags on both sides. And if you remember, the first thing we did when we had bags on both sides is we crossed out the extra bags. So that's what I'm going to do first. I'm actually going to make it so that there's only variables on one side. That'll make me happy. Now, if I try to take away the 7x from both sides, I don't have enough x's on the left to do that. It's going to give me a negative, so I'm not going to do that. Instead, I'm going to subtract this 4x from both sides. So remember when we crossed out the bags, that's really subtraction. So I'm going to cross out 4 bags on both sides. I'm going to subtract 4x from both sides. When I take away the 4x from the left, it's gone, and I'm just left with 9. On the right, notice how I lined up the subtract 4x. I lined it up directly under the 7x because that's what I'm taking it away from. I'm going to take this. I can only take away x's from x's. So 7x's minus 4x's is 3x's. I haven't done anything with this plus 3 yet, so that's still there. So now I have, on my right, I have a variable term and a constant, and on the left, I have the constant. Now, we're used to seeing the variables and everything on the left-hand side and the constant by itself on the right, but it doesn't matter when you're maintaining equality. It doesn't matter which one's the right or left. I'm going to go through my equation solving steps that I've been doing. I'm going to add or subtract the constant from both sides. And I'm not going to subtract the 9. I don't want to be left with nothing on the left. I'm going to take away the constant from the side with the variable. So I'm going to take away this 3 because it's the number with the variable. I'm isolating the variable. I'm removing everything away from the variable and I'm shifting it to the other side. So the opposite of add 3 is subtract 3. Or I can think of it this way. The opposite of positive 3 is negative 3. So I'm either subtracting 3 or you can imagine that you're giving a negative 3 to both sides. Either way, 9 and negative 3 or 9 minus 3 is still 6. And if this is gone, I have 3x left. So now I have a number times x equals another number. So now I do my final step. I divide by the coefficient. So I'm going to divide both sides by 3. Sorry that I'm writing over top this one, but you probably had more room. I'm dividing both sides by 3. 3 divided by 3 is the invisible 1x. 6 divided by 3 is 2. So I think that 2 is what x equals. So now I'm going to do the check. The check is very different. No, it's not very different, but it's a little bit different from what you're used to. So let's go back to the very beginning. 4x plus 9 equals 7x plus 3. And I'm going to bring down the equal sign again. I'm going to now substitute, and I'm going to substitute in 2 for all of the x's. So on the left, I have 4 times 2 plus 9. And you did this with the bags and coins, but still, it's different when there's no pictures. And on the right, 7 times 2, because 7x plus 3. And I want to see if these two things are equivalent when x equals 2. So I'm going to evaluate the left. 4 times 2 is 8. 8 plus 9 is 17. And on the right, 7 times 2 is 14. 14 plus 3 is 17. So look at how the values, the numbers on both sides are the same. If you do this, if you solve and you get done and the number on one side is not the same as the number on the other side, then you do not have the correct solution. That means your check has failed and you need to go back and find your mistake. Just so we're clear, the answer to this question is not 17. The answer is x equals 2. That is the solution. That's why I boxed it. Some people get confused and they think 17 is the answer. No, 17 is the value on both sides when x equals 2. But what we were looking for, the goal was to find what x equals, and we found it. X equals 2. Let me show you another one that would be kind of tricky with the distributive property. So at the bottom of page 11, there are two more examples, letter D, D1 and D2, where we have the distributive property. And D1, if you can do D2, then you can do D1. So let me do the harder one first. What I want you to notice is the difference between D1 and D2 is in D1, everything's positive, all positive, no subtraction, everything's positive. So that'll be easy. But in D2, we have a negative and we have subtraction. So to help us get the right answer, I'm going to do this first. I'm going to rewrite. I have to leave the -3 there. I can't change it. But I can change subtract to add and the 5 to its opposite. I'm allowed to do that. I also noticed that this is even more really challenging because it has a 2x over here. So it's combining two confusing things all in one. So D2 is challenging. Okay, so here's what you're going to do anytime that you have parentheses, whether it's in D1 or D2, is you're going to use the distributive property. The distributive property means that I'm going to multiply the number on the outside the parentheses by everything inside the parentheses. So I do -3 times x and -3 times -5. -3 times x is -3x. -3 times -5 is +15. A negative times a negative is a positive. I still have addition. That's what's between my numbers here, so I bring that straight down. So now I have distributed the -3. It's already looking better than it was. It's already starting to look easier, but then they have to throw a wrench in the works and they give us a 2x on the right. So what we would normally do next is we would add or subtract the constant, but since there aren't any constants on the right, it wouldn't be a very good idea. So remember how we did this in the last problem. When we have variables on both sides, we need to figure that out first. If I go and get rid of the 2x on both sides, then what's going to happen is I'm not going to have anything on the right. I'll have 0 on the right, and I'll have everything on the left. You can keep solving with that. 0 is a number, but I know how you think, and you're not going to like that. So my suggestion is not to subtract stuff so that you eliminate everything on one side, but instead, if there's only one term on one of the sides, then don't get rid of that one term. Let's just use the other one. Let's use the other side. So I have -3x is being added to 15. So the opposite of add is subtract. Well, yes, and I could subtract this, but I would have to subtract a -3x from both sides. Well, subtracting a -3, and I'm subtracting because I'm adding this to 15. Subtracting a -3 is complicated. Really, subtracting a negative is just really addition. So change, flip. I could also think of it this way. The opposite of -3x is +3x. And when I combine opposites together, I get 0. So now that eliminates the 3x over here, and I'm adding, because the opposite of -3x is positive, so I add a 3x to both sides. And that means that on the left here, I have 15, because the other term is gone, and on the right, I have 5x. And now all I have to do is divide by the coefficient. When you get to the point where you have a constant on one side, which is just a number, and you have a variable term on the other side, like a variable with a number in front of it. Once you get there, then you're at your last step and you divide by the coefficient. You divide by the number in front of the letter. 15 divided by 5 is 3. 5 divided by 5 is the invisible 1, x. So I have x equals 3 as my solution. Now I have to check it. And when I do the check, my first step is to always rewrite it exactly as it was before I mess with it, before I did anything with it and change it in any way. I always go back to the beginning because I could have made my mistake anywhere. So now I'm going to substitute. So negative 3 times, and then I exchange this x for a 3 minus 5 equals, and there's another x over here. So 2 times 3. So now to do the work on the left, I have negative 3 minus 5 is negative 2. So negative 3 times negative 2 is 6. And over here, I have 2 times 3, which is 6. So 6 equals 6, and it checks. 6 is not my solution. X equals 3 is my solution. But the fact that both sides equal 6 when x equals 3 tells me that it is the correct solution for this equation. So those were two of the more challenging problems there on page 11. And I did want to show those to you. I also wanted to do one more with you from page 12, and then we will be done. Okay, so I'm now going to do with you number 3 from page 12. So number 3 from page 12, the first thing you may want to do is rewrite this. You don't have to, but you may want to. It's up to you. As long as you can see that as a negative 10, you'll be okay. But I'm going to rewrite it. Because what I want to know is that the easiest thing here would be to add 10 to both sides. But I want to make sure I understand that the opposite of negative 10 is positive 10. So I'm giving a positive 10 to both sides because I don't want to subtract a negative 10 from both sides. That's complicated. I'm going to add 10 to both sides. I'm going to give a positive 10 to both sides. So when I give a positive 10 to both sides, I get negative 9 on the right, and 5x is left over on the left-hand side. At this point, people start to panic because they're like, I can't divide 9 by 5. There's no need to panic. Let me show you what you're going to do. Trust the steps. The next step is to divide by the coefficient. So that is what I'm going to do. I'm going to divide both sides by 5. Divide by 5. Divide by 5. Yay. 5 divided by 5 is the invisible 1x. Negative 9 divided by 5 is negative 9 over 5. Here's what you're going to do, because maybe you don't know this. You're going to put negative 9 divided by 5 in the calculator. You're going to hit enter. And when you hit enter, you're not going to get a whole number. You're going to get a fraction or a decimal. Once you realize that, you're going to stop, go back, and realize I had my answer all along. Negative 9 divided by 5 is negative 9/5. And that is an okay answer. You're allowed to have an improper fraction as an answer in algebra. That's okay. And it's going to work out really nicely when you do your check because you're not going to have to worry about decimals and fractions and stuff. It's going to work out really well, okay? I'm going to substitute this in 5 times. And what goes inside here? What am I using for x? Negative 9 over 5 minus 10. Does that equal negative 19? Well, if you type this in a calculator, negative 5 times and then negative 9/5, enter, and then hit and subtract 10, it's going to work. Here's the reason why. Because when I have a number that I'm dividing by 5 and then I multiply by 5, those 5s cancel out. So really, 5 times negative 9/5 is just negative 9. So negative 9 minus 10 is negative 19. And I really stress this. You should definitely be using a calculator because I don't know that you would know that in your head, but this does check. So sometimes your solutions are going to look like that. They're going to be these ugly, like improper fractions with negatives, and that's actually okay. So just wanted to show you the answer then. Thanks for watching.